In this video, we're going to take some time to explore callback functions in detail. In this section already, I've probably said the word callback or callback function upwards of 20 times, and now it's time for a dedicated video where we really dive deep into the callback pattern to see how it works and how we can take advantage of it by creating our own. Now, why is this so important? Because it's at the core of asynchronous Node.js development. It is something that's going to come up over and over again throughout the class, and it's something that's worth investing in early on in our education, so we're more comfortable with it as we continue to use it. Let's go ahead and kick things off by moving into the playground directory for just this video. I'm going to create a brand new file inside of here. I already have 1 through 3, so I'll call this for-callbacks.js. And in here, we're going to explore callbacks in isolation. Let's go ahead and start with an example we're already very comfortable with. I'm going to call setTimeout like we've done plenty of times before, passing in the 2 arguments it requires. The first is a function, and the second is the amount of time to wait in milliseconds before that function gets called. And we're just going to wait 2 seconds and we'll print a message, console.log, 2 seconds are up. Excellent. In this 3-line example, there is a single callback function, and that is the function we define and pass in as an argument to setTimeout. So this is a callback function. A callback function is nothing more than a function we provide as an argument to another function, with the intention of having it called later on. So in this case, we are providing a function as an argument to setTimeout, with the intention that setTimeout is going to call this function at some point in the future. That is all a callback function is. Now, in this case, we are using the callback pattern in an asynchronous way. As we saw, setTimeout is a node-provided API, and it is indeed asynchronous. Now, that does not mean every time we use the callback pattern, it's actually asynchronous. This is a point of confusion for a lot of people. We've actually already proven this. We know that setTimeout uses the callback pattern and it's asynchronous, and we know that our array methods like forEach and filter use the callback pattern, but they are indeed synchronous. So right here, let's create a const called short names. Actually, let's just call this one names. We'll create short names in a second. And I'm going to toss my name in there along with Jen and Jess. And the goal is to use callbacks with filter, something we've done before. So const right here, short names equals, I'll access names.filter to use the filter function. And once again, we're going to provide a callback function. I'm passing a function to another function with the intention of having it get called later. So right here, this callback function, as we know, will actually get called one time for each item in the array with the individual item. In this case, we could call it something like name. And all I'm going to do is return true if the name has a length less than or equal to 4. Those are the short names we'll keep. So return name.length less than or equal to 4. In this case, we are indeed using the callback pattern as well, but there's nothing asynchronous about filter. It's not interacting with a native Node API, it is just standard JavaScript code, completely synchronous. So far, the only time we've used the callback pattern is when we're working with a function that we never defined. So we pass a callback to setTimeout, that is a Node.js API, and we passed a callback to filter, also not defined by us, that comes from JavaScript. Now, this is not to say it's never useful to define your own function that takes a callback, because it actually is, and it's something that we're going to use in the very next video. So let's take a quick look at app.js. Imagine in my program, there are 4 different places where I want to be able to take a location and get the coordinates back. So I want to be able to geocode. Now, what is that going to look like? Well, if I have 4 or 5 different locations I need to do this, I have to take this code and I have to put it in 4 or 5 different places, and obviously that's not ideal. So what we would do is we would create a function called geocode or something like it, and all of this code would go inside of there. Now, in order to get that done, we're going to have to be pretty familiar with the callback pattern. So let's go ahead and see what this would look like over inside of the callbacks playground file. Let's create a constant, and I'm going to call this constant geocode. Now, this is indeed going to be a function we define. and we're going to set this function up to take in a callback function, much like setTimeout takes in a callback, and much like filter takes in a callback. Now you can take in as many arguments as you need along with the callback. For example, setTimeout takes in the function as well as the amount of time to wait. For geocode, we could say that you need to provide the address, otherwise we don't know what address to geocode, and we can say that you also need to provide a callback, which is the function that we'll end up calling once we have the data. Now, for the moment, we're not actually going to do any geocoding inside of here. We're just going to make up the results to keep things simple. So for the moment, let's create a const called data, and we'll just set up latitude and longitude properties, setting up random values for each. So on data, I'm going to set up latitude as a property, and I'll just set the value to 0. Then we're also going to have our longitude, and I'll set that to 0 as well. So let's say that at some point in the future, yes, we get this data back by calling request. Now, what do we do with it? The goal is to give it back to the caller of geocode. So if I call geocode and pass in an address like Philadelphia, I want to get access to those coordinates. Now, we know there are two ways I could get this done. One, it could be the return value from the geocode function, like we've seen with pretty much every function so far. Or we could provide a callback and get the data there. Now, if this was our actual function, the choice would be easy. I would ignore and remove that callback argument, and I would just return the data. Then down below, I could access that data, const data equals whatever comes back from geocode, and I could use it. Down below, console.log data. Perfect. Let's go ahead and save the file in its current state and move over to the Playground folder to run things. So that's going to be cd:/playground to get over there. Once we're there, I will clear the terminal output. And from here, I'm going to run the file. So node for-callbacks.js. Now, when I run it, I'm going to expect to see my data showing up, and it is. And then 2 seconds later, I get my little message from the example up above. The problem here is that there's nothing asynchronous happening inside of here. Later on, we're actually going to use request inside of here, and we know that's asynchronous. For the moment, as we explore the callback pattern, let's just use setTimeout to simulate this delay. So I'm going to take all of the code inside of the geocode function. I'm going to use Command X or Control X to cut it out, copying it to the clipboard, because we'll paste it in just a second. From here, I'm going to use setTimeout to simulate a delay, and let's go ahead and provide the function to run when we're done. And we'll provide the time to wait. To keep things easy to see in the terminal, I'm going to pick a longer than average time. I'm going to stick with 2 seconds, though in reality, this process would take just a fraction of a second. Then I'm going to paste the old code exactly like we had it inside of the setTimeout callback. Now let's go ahead and run the program again to see what happens. In the terminal, I'm going to use up and enter, and we can see that right away, much shorter than 2 seconds, we saw undefined printing. So the problem here is that geocode, this function, it's not returning anything. Look at what's inside of this function. There is a single call to setTimeout. There is no return statement directly inside of geocode. So geocode finishes almost immediately, and if you don't return something from a function, we know that JavaScript will implicitly return undefined. So that is what we end up seeing. Now, yes, there is a return statement in geocode, but it is nested in another function. So that return statement is returning from this function, not from this one, which is why we're not getting a value back. So the return pattern is no longer going to work for us when we start to do asynchronous things inside of our functions. And that's where the callback pattern is going to come into play. So let's change our code to use callbacks and get it back to a working state. The first thing we're going to do is remove the expectation we have right here that geocode is going to return some sort of useful value. That's not going to happen. Remember that when we explored how everything works behind the scenes, none of our callback functions, the ones that go to Node APIs, then come down to the callback queue, they don't get executed until the call stack is empty. That means main has to finish. Right here, we're trying to say that one of those callbacks should finish before main finishes, and that's never going to happen. So we have to adjust. What we're going to do is we are going to remove data and remove our console.log. geocode is not going to have a direct return value, and that's okay. It's expected. What we're going to do from here is provide that second argument. The first one is address, currently Philadelphia. The other one is a callback, which is just going to be a function. So right here, I am going to provide a function as the second argument. Now, you could have reversed the order or added as many or few arguments as you needed. In this case, 2 was the perfect amount for us. Now, this callback function is going to get fired at some point in time. The question is, what things are we going to have access to? Well, that's up to us to choose. So right here, instead of returning the data, we're going to go ahead and call the callback function, passing the data in as that first argument. So if we're calling the callback with data as the first argument, that means we're calling this function with data as the first argument. So right here, I can name that first argument so I could access it. I'm going to call it data, but I could call it anything I wanted to. This name does not need to match up with this name. It is the position that matters. Here it's the first argument, down below it's the first argument, and now we can use it. So console.log data, and now we're using the callback pattern in our little fictitious example. So let's go ahead and run the program one more time. Now we're going to wait those full 2 seconds as expected. We then get access to the data, we call the callback, our message prints, and what are we seeing down below? I am seeing my latitude and longitude showing up, which is a great step in the right direction. So if our function is completely synchronous like geocode was before, we're able to use return to get a value out of the function and back to the part of the code that called that function. When our function starts to do something asynchronous though, that's no longer an option. So instead of returning a value, we take a callback in and we call the callback with the value we want to send back when we have it. This accomplishes the same goal as the return statement does. It still gets the value back to the code that needs it. Now that we have this in place, it's time for a quick challenge where you're going to do something similar, creating a little function that uses the callback pattern. Once we're done with that, in the next video, we're actually going to use the callback pattern inside of app.js with our geocoding and our weather fetching functionality. So to find the challenge for this one, we can head over to a URL. That's links.mead.io/callback. This is going to redirect us over to another GitHub gist. And all we're going to do is take all 11 lines of code and we're going to bring them over to our 4 callbacks file. Now, before I paste them in, I am going to highlight all other lines and comment those out so nothing else is running, though I'll keep them in place as a reference for the future. And down below, I'm going to paste the challenge comments in, and we'll notice that this challenge also comes with a little bit of JavaScript code. The goal here, as stated, is to mess around with the callback pattern like we did up above for geocode, and like we did for geocode, we're going to stick with a simple setTimeout call to simulate some sort of asynchronous process. Now, you're going to define an add function that accepts the correct arguments, and the usage is actually down below. So add takes in 3 arguments. It takes in 2 numbers. These are the numbers that get added up, and it takes in a callback, which is going to get called after a 2-second delay with the sum. Then the code prints the sum. So your job is to get this code working. Now, what's step 1? Define the add function with the correct arguments as seen below. Step 2, use setTimeout to simulate a 2-second delay. After those 2 seconds are up, call the callback function with the sum. That means you're calling this function with the correct sum. Then you're going to test your work. If your definition of the add function is correct, when you run the program, you should see the number 5 printing after 2 seconds. All right, take some time to define that function right here. When you're done, come back and click play. How'd that go? I'm going to kick things off by creating a brand new variable, const add. I'm going to set that equal to a new function. And this function is going to need to take in all 3 arguments. We have 2 numbers and the callback. So I could use something like a and b or x and y, then the callback function, which is typically called callback, but it could be called anything you wanted to call it. Next up, we have to simulate an asynchronous process by using setTimeout to cause a 2-second delay. So right here, I'll pass in my callback function and 2000 milliseconds as the second argument. That brings us to step 3. After those 2 seconds are up, we want to call the callback function with the sum. Remember, I can't use return here because I'm returning from this inner function, not from add. So instead of using return, I will call callback. Now, what am I calling it with? A single argument, the sum. That's going to be a plus b. Now, maybe you created a sum variable first and passed that in, or maybe you added them up right inside of the arguments list. Either way would get the job done. Now, from here, we can test our work. I'm going to save the callbacks file. I'm going to rerun things down below. We wait our 2 seconds, and what do we get? We get the number 5 printing. So now we have a bit of experience working with this callback pattern. We've seen it used with set timeout to simulate the asynchronous process, and in the next video, we're actually going to use it with our request calls where we get that HTTP request data back. Let's go ahead and wrap this one up by removing those challenge comments. I'm going to save this playground file, and in the next video, we're going to move back into the weather app directory. I'm excited to integrate callbacks into our weather application, so let's go ahead and jump right in to the next one.